Welcome to PLCs. I'm Jason Fisher. We were tasked with converting a Logix 5000 program into a Logix 500 program. The goal of the program was to be a car counter for a parking lot. There was also an extra credit opportunity to put in a flasher, for lights to attract customers in. The actual program itself we built, and then we also labeled everything with terse comments. That way anybody would be able to understand it. That's everything in the yellow. The actual lot flash and the car counter itself are both located in subroutines to not dilute the actual main program, so that way you can diagnose the logic in the actual routine. The input and output diagrams we drew out on paper physically to be able to assess the logic as well.
Hi, I'm Alex, and I will be reviewing the logic in our program here. So whenever stop button's not pressed, when your start is pressed, this will be turned on, which locks itself on so it stays on. If it's not powered on, we'll use this jump instruction to skip all that to save processing time. But when it is turned on, we activate the MCR, which acts as a cutoff for all the stuff inside of it for safety purposes. Then here is our jump to our first subroutine, which is our car counter. And in this subroutine, whenever a car enters the parking garage, the counter goes up. Whenever a car exits the parking garage, the counter goes down. Whenever the counter is full or above the preset value, the lot full light comes on. Here is our extra credit light flashers. Timers are triggering each other to pulse these lights in sequence. Okay, then after our lights, we use our return instruction to go back to our main program. And here we have our label instruction, which is where our jump from earlier goes to. And there's our reset button, which triggers our car counters to reset. And then here, when our car counter is not full, we go to our flashing lights that attract people into our parking lot when the lawful light is not on. And then here I'll show you guys it counting. There's it going up to 149. Turn it off, turn it back on again. There's that 150 and see our lawful light come on. And then turn this one on, and it goes back down to 149, and the lawful light comes off.
Hello, my name is Daniel, and I'm going to give you a brief description of the hardware and how it relates to the program for the garage car counting program. If you notice, first of all, what we have here is the I/O list, and on this I/O list we have our hardware inputs listed as input channel 0, bits 0 through 5, and then we have our outputs, they're 0 through 3. As you can see, they are labeled. Now those outputs, inputs and outputs, are hardwired, as you see right here. This is the general powering of the circuits. We have our main power coming in, going down through our e-stop switches, main start, the main master control relay, controlling whether these will be scanned or not, operational or not, I should say. And you can see that the PLC power supply is below that with our PLC input module, and then our PLC output modules. The MCR is just below that. Over on the right, we have the actual inputs. As you can see, the inputs relate to the input list and output list that we previously discussed. So we have start, stop, start to, enter, cars entering, cars exiting, and the reset of the counters for the inputs. The proper NEC standard symbols that were required for the lab. Over on the right, we have our outputs. We have lot full, and it's a little hard to read, but we have red, green, and yellow lights that will flash when the lot is empty, able to take cars in. Now, how this all relates is you can see over here, this is our main program, and all of those inputs, you can see input 1 :/0, that's the first input. That would be our stop button. Then we have our start button.